Um, I don't know. The left-hand side has a fraction. I guess that's, quote, more complicated. So we can start with the left-hand side. But you know what? It doesn't look like there's much we can do. There's no squares, so I can't use Pythagorean identity. They're already converted to sines and cosines, so it's already as simplified as possible. So the idea or the technique was, if you're completely stuck and you don't know what to do, if you notice you have a binomial, which we do here, give conjugates a shot. Sometimes it works out. So we'll go ahead and use conjugates. We'll multiply the numerator and denominator by the conjugate of, in this case, the denominator. 1 minus sine x, 1 minus sine x. I typically do not multiply out the non-conjugate, so I'll leave the numerator in factored form. Sometimes it's useful, sometimes it's not. I can eventually go ahead and multiply by n anyway. And then the denominator is, what's that? That's 1 minus sine squared. So the reason why I use conjugates is it will produce squares, so you can use Pythagorean identities. So according to Pythagorean identity, the denominator, 1 minus sine squared, is just cosine squared. So of course we can see that one of the cosines will cancel out. Notice what we have here. We have basically one giant fraction. And our goal, if we scroll up, because I don't want to constantly scroll up, is secant x minus tangent of x. That is, our goal is two separate terms, and we currently have one giant fraction. That is usually a telltale sign to split the fraction. So I'm going to split the fraction. The 1 will get its own cosine minus. The sine will get its own cosine denominator. And what do you know? That's precisely what we want, because 1 over cosine, the reciprocal of cosine, is secant, and sine over cosine is tangent. That is precisely the right-hand side.